In this video, we are going to learn about linear independence vectors and linear. So, what is the criteria for independence vector means? So, if the rank is equals to the number of vectors, then the vectors is said to be the independence. Then, what is the criteria for dependence means? If the rank is less than the number of vectors, then it is said to be the linear dependence vectors. Okay. So with this criteria, let us solve few problems. The problem one is vectors is given vectors is 1 and 2 and 3 and 6. So vector 1 is 1 and 2, vector 2 is 3 and 6. Let us check is any dependence or not. Okay. So first let us solve by this criteria. Later I will show you one trick. Okay. Write the vectors in terms of matrix to find the rank, right? We need rank, right? So that's why write the vectors in terms of matrix. If you write so, you can arrange like this 1, 2, 3, 6. Okay. Now do the uh, row operations. Row operations, I think you all know, like multiplying the row or adding or subtracting the rows. So like this, you need to perform the row operations. While seeing this, you can state that like the row 2 is which is equals to the 3 into row 1, right? Like 1 3 is 3, 2 3 is 6. So row 2 which is equals to the 3 into the row 1. So do like this, like R2 which is equals to R2 minus 3R1. If you do so, we will get the R2 as zeros and we are left over with 1 and 2. Then with the criteria, what is the rank now? The number of non-zero rows are 1. So rank equals to 1. Number of vectors are 2, like vector 1, vector 2, right? Number of vectors are 2. Now, while seeing this, you can state that rank 1, which is less than number of vectors, which is 2. So, with what is the criteria this thing? This is the criteria for the dependent vectors, right? So, therefore, the given vectors are dependent. Just now I said to you, I will give you a trick in this dependent and independent. So, let us check for the dependent. So we have proven this as a dependent vectors. So we have vector 1 and vector 2. In the combination 3 vector 1 which is equals to vector 2, right? So which is a dependent. Okay. Scalar of one vector which is equals to the another vector, simply a dependent. Okay. Let us move to the one another problem. In this the vectors are 1 0 0 1. So we can directly state it as independent because the rank is 2, vectors are 2, rank 2 which is equals to the number of vectors which is equals to 2. So it is a condition for the independent. Okay, directly from the question seeing you can see. So now let us move. I hope you got the idea on this topic. If you learned anything in this video, please do a like and support by subscribing. Thank you for watching this.